Hello everybody, this is Mr. Kusaj, and we are ready to start Chapter 8. Vectors. Chapter 8.1, Introduction to Vectors. What is a vector? Well, a vector is a quantity that has both magnitude and direction. Okay? So it gives us two pieces of information. Which direction and for how long. So we have a diagram of a vector. Let's look at the one on the left first. Vector is basically an arrow or array, and it has a starting point, right? Initial point or tail, an ending point or terminal point or the tip, and we label it at the ends like this. That's one way to label it. Or we can skip that and just give it one lowercase letter in the middle like that. So you could say this is vector AB with capital letters, or you can say vector A and be done with it with the small letter. So what we're saying here is there's something that's going that direction. Okay, so that's the direction. But also, it's not going forever, like a ray, if you remember in geometry. It goes from here to here. This direction and from here to here. So it gives us two pieces of information. If we take that vector and put it in a coordinate plane, then obviously the easiest or the most convenient spot to put it on to start it is at 0, 0. And then because it's here, we can count the boxes and figure out how long it is and figure out the angle. So for example, this vector happens to be going 35 degrees. Okay, so just a way of labeling it. We say that the vector is in standard position. So if your vector starts at 0, 0, that's a standard position. It can start anywhere, but it's very convenient if it starts in the standard position. So as I said, the notation, you can call it vector AB with the capital letters, vector A with the lowercase letter, or just little a, because the whole chapter is about vectors, so we don't have to say we're talking about vectors. That's what the chapter is about. Okay? The magnitude of A, right? So if you're only talking about the magnitude, so if we go back here, say that's 2 inches long. So the magnitude is 2, right? We would say the magnitude of A. Instead of writing the magnitude, the word magnitude, we just put these bars here. That means magnitude of A. Okay? You'll see more of that later. But right now, let's go back to talking about the vectors. One thing you need to know, it's easy to measure how long the vector is, right? The magnitude. You just take a ruler. But bearings, you have to know angles, right? Which direction you're going to. So you have to know angles, otherwise known as bearings. Bearings refers to northeast, southwest, right? So if you were to write them in on paper, you know this. North is up, south is down, west is left, east is right. So there's two ways of expressing direction, right? So we can do 0 to 90, but if you want to do 0 to 90, then you got to tell me which quadrant you're in, right? So every quadrant is 90 degrees, so express which quadrant you're in, and then give me the angle that you're going in that quadrant. So for example, this angle is 35 degrees. But if you just say 35 degrees, compared to what? Right? But if you say south, 35 east, then what you're saying is you start at south and then turns towards the east 35 degrees. So now we all know which direction we're going. South, 35 east. If I would have said north 35 east, then you start here and go 35 towards the east. North 35 west would be this way, right? So you need the two letters, the two directions on either side of the angle. That's one way to do it. Another way to do it is to just look at the whole circle from 0 to 360. And if we start the circle at north, just tell me the angle. So that angle in 0 to 360, we would call 145. Right? That's 35. So from 180, 35 from 180 would be 145. So that angle is 145. So this angle, you can call it two ways. But you have to put the word true next to it to show that we're not doing it this way, we're doing it this way. Right? Starting from true north, turn 145. So what would this angle here be? That would be 300 and something, right? All the way across would be like 300 something. Okay? So it's just two ways of expressing directions. Okay, let's get back to, now that we know magnitude means it's written like that and it means how long the arrow is, and bearings or direction is in angles, let's go back to talking about vectors. Okay, there we go. So vectors can be parallel, equivalent, or opposite. So what does all that mean? Let me cover this. That's the next page. You don't need that yet. So if you look at these two vectors, okay, they're definitely parallel. They're definitely going the same direction, but they're not equal. This is longer than this. So vector A is not equal to vector B. But you could say A is parallel to B. You could say that. Look at this one. Neither, right? They're neither equal nor parallel. A is not equal to B and A is not parallel to B. Look at the third one. A is equal to B. Right? A is equal to B. Same direction, same length. Okay? What else do I have here? Oh, yeah, opposites. Yeah, opposite, just like numbers, opposites means negative. But because vectors involve directions, negative means the opposite direction. Right? So if you're going this way, then if you're going to be equal but opposite, then you're going to go this way. So they're equal but opposites. Okay? Resultant. Resultant is when you add vectors. Okay? How do you add arrows? Well, drawing. There's two methods. The triangle method, which is also called tip to tail. What you do is, let me cover up here. Right? So I want to add this vector plus this vector. I want to add vector A to vector B. Right? So if you move something this direction, and then from there move it that direction, where do you end up? Well, first of all, they're far apart. So the way we add them is you have to move one to the other. Right? Move B to A. But move it tip to tail. Right? So here's the tip. Move this tail and attach it right there. So somehow, okay, don't copy this just yet. But somehow you have to, hold on. Somehow you have to pick up vector B and redraw it right next to or attached to A. But it's got to be the same vector, right? So somehow you got to pick that up and draw it right there. See that? Now, right, go this way, go this way. So the resultant would be you started here and you ended up right there. Okay, so how are we going to do that if they're drawn on paper. How do you actually move it? Well, you redraw them. You redraw them. So here's A. I drew A. And then B, I redrew it so it touches A, tip to tail, right? So the resultant, the sum, the resultant would be this dotted part that's in red. You started here, you went to here, then you went to here. So the resultant was you started here, you ended here. I'm done. I added these vectors by moving one to the other, tip to tail. Okay, this is the one that most people do when they do drawing of the resultant. There's another way of doing it. It's called the parallelogram method. That's tail to tail, and you're going to end up with a parallelogram, right? So let me cover that up first. So here's A, same vectors as before. Here's A, and then B, you got to copy them exactly the way they are. There's B, right? There's B. Now, this is tail to tail. Now I'm going to create I'm going to create a parallelogram, right? So like that, and like, it's got to be a perfect parallelogram, right? Parallel, 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 right? So what? Well, if you draw the diagonal, that will be the resultant. Okay, so in your notes, copy it this way, right? So you redraw A and B together, right, at the tails, together, tail to tail, and then create a parallelogram with those two sides. See the parallelogram? And then once you have the parallelogram, the diagonal, right, draw the diagonal will be the resultant. And if you look at the two answers, aren't they exactly the same? Look, you're going the same direction and the same distance. Okay? Again, I said, from what I see, most students like to do it this way, the triangle method. Okay? Some examples. Here is vector x and vector y. What is 2x plus y? Well, what this means is double x, right? Twice as long, right? Twice as long. So when I draw 2x, I'm going to draw this and then double it. Plus y. What that means is you put y, redraw y, tip to tail, and then make a triangle. There it is, right? Look carefully. Here is my 2x right there, x, 2x, and then I draw the y so it's tip to tail, and my resultant, 2x plus y, when you add those two, is this red arrow right here. Okay? One more time. Oh, I did it both ways, the triangle way and the parallelogram way. Another example. So same vectors, but now I want negative 2x plus y. What does that mean? That means you want 2x, but in the opposite direction, right? So look at x. You're going to draw it pointing to the left and draw it double the length, and then add y. Isn't this it right here? So here's my negative 2x, x going to the left, negative 2x, and then tip to tail, draw y here. Not over here, here. There's y. And connect them like that, and there's your answer, negative 2x plus y. You could get fractions. This is the final example. You could get a fractions. So there, you take a ruler or estimate. I don't want the whole x, 1x. I don't want all of x. I don't want half of it. I want 3/4 of x. And then I want to add it to y. No, I want to add it to 2y. So look at it. So x would have been all the way to here. This would be about half x. So 3/4 x is here. So there's my 3/4 x vector. Then I add y and another y, 2y, and I'm done. Draw the resultant, and you're done. Okay? That's it for part 1 of 8.1. See you in a little bit for part 2. All right, bye.